good to see you back. That's what's up. Looks like you're looking for a little practice. Good thing I got it for you. Let's get right into it. So I got 3 matrices over here. Some are the same dimensions, some are not. Maybe that'll come into play later. Hint, hint. All right, let's get to it. Number 1. Okay, so I got a number in front of the name of a matrix. So this is that scalar multiplication we were talking about. This is my scalar, -4. And I'm going to multiply that -4 times the entire B matrix. Let's do a little bit of substitution here. Oh yeah? Yeah, exactly right. So in place of B, what I have is the entire B matrix. So this -4 gets multiplied by everything in the matrix. Looks something like this. Yeah, there are 4 things in the matrix, 4 things get multiplied by -4. So let's do it. What's -4 times 2? Yeah, -8. -4 times x. And I know you're used to seeing numbers in there, but we can multiply numbers times letters, right? What is -4 times x? Yeah, -4x on that same line. -4 times 3y. -12y, exactly right. And then finally, -4 times -4 is +16. So -4 times the matrix results in another matrix, the same size, all of the entries multiplied by -4. Good. Let's kick it up a notch. Oh yeah. So we still got that scalar multiplication, but let's add in some addition to it. Why not? Let's do it. Ready? I'm gonna just go ahead and replace these now. Okay, so this is exactly what I did. I went ahead and replaced A with the matrix A is equal to, and I replaced C with the matrix that C is equal to, but looks like it's gonna be an issue. Look at the size of this matrix A. Even after I double all of these entries, what's gonna be the size of matrix C or the result matrix? Are they gonna be the same? Can't do it. It's undefined. You can't do it. The dimensions don't match. So you cannot add together 2 matrices if the dimensions don't match. Well, let's put together 2 that do match. Here we go. Much better. This a 2x2 matrix. This will be a 2x2 matrix. I can add those together. However, first things first, I got to do this multiplication first. Don't forget PEMDAS. So before I can add these together, I got to do that multiplication first. So let's do it. All I did was multiply, add 2 times everything in the matrix. Here we go. Now I can add these together. Now remember, from adding a 2x2 matrix to another 2x2 matrix, I better get a 2x2 matrix. Let's talk about this addition. Position by position. Let's do it. 2 plus 14 equals 16. Exactly right. Next, x plus 8. Now those aren't like terms, right? So when I add x plus 8 together, what's that going to look like? X plus 8. Exactly right. You just write them down beside each other. If they're not like terms, you can't combine them. You just write them down beside each other. Same thing for the next one. 3y plus -4, which is the same as saying 3y minus 4 equals, exactly right, 3y minus 4. And then finally, -4 plus -6 equals -10. Exactly right. Answer. Good job. All right. One more. This is kick it all the way up. All the way up. Ready? Oh yeah. Now we're talking. Now we're getting into some real math. So here we go. It says find x and y values to make this equation true. Notice we're looking at an equation, hence the equal sign. Just doesn't look like what we're used to as far as equations go. But knowing what we know about matrix addition, I bet we can come up with something. So, first off, are they all the same size? 2x1, 2x1, 2x1. We're good. Let's see if we can't, Now, if these are all in the same position, can I write them down where they are as an equation? Let's do that. 2x plus -5, which is like saying 2x minus 5, equals 9. Man, I bet we can solve that real easy. Add 5 to both sides. Divide both sides by 2x equals 7. You knew how to do that already. So, 2 times 7 would be 14. 14 minus 5 is 9. Ha! X equals 7. I bet we can do the same thing for y. Exactly right. Watch this. Bang. You knew how to do that too. But now you know how to do this. Thanks for coming to check this out, man. I hope this helps. See you next time.